Okay, let's take a look at surface areas of regular pyramids and cones. First thing we need to do is write down the formula, which is total area is equal to the lateral area plus one base. Again, pyramids only have the one base. So, how do we find the lateral area? Well, again, our shapes are no longer rectangles, they're triangles. So it's 1/2 times the perimeter of the base times the slant height. Remember, the slant height is this height of the triangle. It's listed in blue. I'm going over it in green here so you can see a little better. But that's the height of the triangle, and all of these triangles are slanted over into the middle, and so they all touch right there. That's the slant height, and then plus whatever your base is. Well, our base in this case, regular pyramid, so we've got a regular four-sided polygon, that's a square. So this is going to be 1/2 perimeter times the slant height plus the side squared. And now then, plugging in the values, 1/2 of, well, the perimeter of your base is 5 plus 5 plus 5 plus 5, that's 4 times 5, it's 20, times the slant height, which is given, and that's also 5, plus, again, the side squared, the area of that base is just 5 squared. A whole lot of 5s in this one. Well, the lateral area, multiply the 20 times 5 together first. That's going to be 100. So it's 1/2 of 100, that's 50, plus 5 squared is 25. So the lateral area 50 plus the one base gives you a total of 75, and our units are inches squared. All right, now take a look at this one. Regular pyramid. What kind of a base is this? Well, because it's regular, it's an equilateral triangle. So we've got to use the same form. Lateral area plus the base. That's the 1/2 the perimeter times the slant height plus. How do you find the area of a triangle? Well, that's 1/2 the base times the height of the triangle. Again, it's not the height of the pyramid. The height of the pyramid is not shown, but we've got to say that's the height of the triangle. The lowercase b means it's the base of the triangle. Well, let's fill in what we know, and then we'll figure out the rest. The perimeter, because it says regular, that means this side length of 2, this side length of 2, and this side length of 2 gives us a perimeter of 6, times the slant height, the height of the triangle, is given as 5 plus 1/2 of the area of the base. Well, that's this green triangle. We've got to figure that out. The base we already know. That's the 2. That's the side length. It's the height that we don't know, so let's get that. Here's the equilateral triangle. All of our angles are 60 because it's equiangular and equilateral. When we drop the altitude here for this equilateral triangle, that's going to split the sides into 2 equal halves. Well, since the sides are 2, 2, and 2 for the bottom, this is going to be 1, and this is also going to be 1 over here. So we have two 30, 60, 90 right triangles. Here's one that I'm outlining in blue now. And what's the relationship? If you know the short leg, how do you get the longer leg? You multiply by the square root of 3. So it's going to be 1 times the square root of 3. That is the height, and that's what we're looking for. We'll put that in red over here. That's the height of this equilateral triangle. So now then, all we need to do is calculate these values. Half of, let's take 6 times 5, that's 30. Half of that is 15. Plus, well, now half of 2, that's just going to simplify to 1 times the square root of 3. So the exact surface area, the whole surface area, is 15 plus root 3 centimeters squared. Now again, you can punch that in on a calculator. When you do, you get the approximation. You can take it to as many places as you want. I'm getting 15 plus root 3, and that comes out to be 16.732. Let's use 732 instead of 723. 732, and again, centimeters squared. That's the approximation if you need one. All right. If not, then that's fine. All right. Find the surface area of the regular pyramid. Again, we've got an ugly base because it's not a nice shape. It's regular, but it's a pentagon. So this is going to take some more time. But notice they've given us the apothem length. You see this? I'll mark it in green. This length right here is the apothem. Well, if they give us the apothem, all we have to do is use that formula. So it's really not as bad as what you would think. So let's use the formula. Lateral area plus the one base, or 1/2 times the perimeter of the base times the slant height plus the area of the base, which is a polygon. Let's go ahead and put in the formula there. 1/2 apothem length times the perimeter. You notice these two, the lateral area and the base, they both have the half and they both have the perimeter. So really the only thing that we need to fill in are the slant height and the apothem, and both of those are given. So 1/2, the perimeter is, well, it's 7 here for this right side, then 7, 7, 7, and 7. That's 35. The slant height is given as 15. Again, that's the height of the triangle right here. Putting it in red so it's easier to see. And that's given as 15. Plus, we've got 1/2 of the apothem length. This green segment over here, that 4.8, times the perimeter, which we already know is 35. We got the 35 half on both of those. So again, multiplying the 35 times 15. 35 times 15 is 525. I'm just going to leave the 1/2 for a minute. Plus 1/2 of 4.8 times 35. That comes out to be 168. Well, half of 525 doesn't come out real nice. It's not too bad though. Just take 525 divided by 2. That's 262.5. That's the lateral area, 262.5 meters squared. Plus, now this one is nice, half of 168 is 84. So add that 84 with the 262.5, and when you do, that's going to give a total of 346.5, and again, meters squared. Those are the units. All right, let's go on to this problem. Now we're dealing with a particular type of pyramid, which is cone. It's got a circular base. Well, the formula is still the same thing, but we can go a little more specific on it. We'll write the lateral area plus the base. That's 1/2 the perimeter times the slant height plus the base. But because it's a circle, the perimeter is 2 pi r. We'll plug that in. Times the slant height. Plus, well, because we know the circle is our base, we can use the formula for the area of a circle, which is pi r squared. And we've got all that information. Now, like we did in class, the 1/2 and the 2 here are going to divide out every time. So this is just going to be pi times the radius, which is 3, times the slant height of 8, plus pi times 8 squared. This one will definitely leave in terms of pi because it's nice numbers. 3 times 8 is 24, so the lateral area is 24 pi, plus the base area. Well, that's, I messed up. That's supposed to be a 3. There it is. The radius is 3, not slant height in there. So plus 9 pi, which gives us a total of then 33 pi, and our units are inches squared here, because we're doing surface area. So again, once we have those values plugged in, that's a pretty easy one, nice to leave it in terms of pi. Let's take a look at this one. All right, we've got a cone again. So using the same formula, write it in. And writing it helps you remember it. This is 1/2 perimeter slant height plus the base. That's for all pyramids. And then specifically for the circular base, 2 pi r times slant height plus the pi r squared. Again, the 1/2 and the 2, like I said, these will divide out every time, but I still keep them in there. Pi times the radius. See, now, if you look up there, you see the 2, and that's what you want to use, but that's the diameter. So the radius is 1, and the slant height is 1.7, plus pi times the radius, which is 1. Make sure I write the right one down this time. So this is just going to be 1.7 pi plus 1 pi, or adding these together, this would be 2.7 pi, and the units are meters squared. So the lateral area was 1.7 pi meters squared. The base area was 1 pi, the area of that one circle. Next one here. Surface area for the right cone. Well, this time they don't give us the slant height, but they do give us very nice numbers. This is 9 here for the radius, and the height of the cone is 12. These are sides of a right triangle. Not any right triangle, but a specific one that we've had so many times. You look at the 12 and the 9, they're both multiples of 3. This is 3 times 3 down here on the bottom. This is 3 times 4 here on the side, which means the hypotenuse of this right triangle, this is a 3, 4, 5, and so this has to be 3 times 5, or 15 for the slant height. Again, they don't give it directly, but that is pretty easy to figure out. If they didn't have nice numbers, we would just use the Pythagorean theorem to go through and find them. Well, let's plug in then the formula. So this is going to be 1/2 perimeter times slant height plus the base, and then the most specific 1/2 2 pi r slant height plus pi r squared. Simplifying the 2 and the 1/2 again, and then just writing down the numbers. We have pi times our radius is 9, the slant height of 15, plus pi times our radius 9 squared. Well, 9 times 15 is 135, so this is 135 pi. That's the lateral area in yards squared, plus 81 pi, and that's the area of the base, the circle. Adding these together, we get 216 pi, I believe. And again, yards squared. Let's double check. Yep, 216 pi, that was it. All right, let's take a look at one more. Or not, that was it for this section.